lesson, we are going to learn how to verify whether a function is a solution to a differential equation. So let's look at how you are going to do this. So let's say I have this equation here, say x squared equals 4. If I ask you to find the solution to this equation here, okay, the answer will be x equals 2 or x equals minus 2. Okay, these two values here, which is 2 and then minus 2, will be the solution towards this equation here. What does this mean? What this means here is that when you substitute these x values here that we have, which is 2 and then minus 2, into this equation here, we are going to get the left hand side to be equal to the right hand side, and that will give us what the solution towards this equation here. Assuming that when we substituted the value of what x here, which is this 2 and then minus 2 here, we didn't get the left hand side and then the right hand side to be equal, then that means what these x values are not the solution towards this equation. So let's see. If I want to verify whether this x values is a solution towards this equation here, all we have to do is what substitute what the x values into what the equation. So in this case, I have what 2 squared to be equal to what 4. Let's see whether this is true. And of course, 2 squared will give me what 4, and that will be equal to what 4. So the left hand side is this match of the right hand side. So what this is true. So x equals 2 is a solution. Let's do the same for x equals what minus 2. So that was minus 2 squared equals what 4. Let's see if the left hand side will be equal to the right hand side. This will give me 4 equals what 4. So the left hand side is equal to the right hand side. So x equals minus 2 is also what a solution. So this is just to tell us that what a solution to an equation is what is a set of values, okay, that when you substitute in place of what the variable in that equation will satisfy what the equation, meaning what the left hand side of the equation will be equal to what the right hand side of what the equation. So it's this same idea that we are going to what apply to what to verify whether a function is a solution to what a differential equation. And you know, solutions to differential equations are always what functions. So let's apply that idea here. So we have to show that what y equals x squared is a solution to the differential equation y prime equals what 2x. So what that means here is that for this function y equals x squared here, okay, when you substitute its first derivative into this equation, the left hand side should be equal to what the right hand side. That's all that it means. Another way to rewrite this clearly for us to understand is that I'm going to write y as a function of what x. So that what f of x equals what x squared. Okay, therefore this will become what the f of x over the x. Okay, that's the derivative of what f of x with respect to what x equals what 2x. Okay, so you see that out here, what with this differential equation that we've written here, okay, with the derivative written in this form, you can see clearly that what we are trying to see that what there's a certain function f of x, okay, that when you find its first derivative, you get what 2x. Okay, and we give what this function here. So what you have to do is that what find the first derivative of this function here and see whether what when you substitute it in place of this value here, you get what the left hand side or to be equal to the right hand side. If you get the left hand side to be equal to the right hand side, then that means what the function here, which is f of x, satisfies what the differential equation. So therefore it will be a solution to what the differential equation. So we know this function f of x here, okay, so we just need what its first derivative so that we can substitute into what this differential equation and then find out if we get what the left hand side to be equal to the right hand side. So let's do that. So we are going to find the first derivative of this function here. So that will be the f of x. Okay, let me write this again. The f of x over the x. Okay, and that will be equal to what? Applying the power rule here, we have what 2x to the power what 1, and that what 2x. So therefore we have what the f of x over the x to be equal to what 2x. So we found what the first derivative of what the function what f of x. So therefore we are going to substitute it into what this differential equation and see what whether what the left hand side will be equal to the right hand side. So this the f of x, this is the f of x that I have here. Okay, the f of x over the x is the same as what I have here. Okay, you know that what from here we know that what the f of x over the x equals what 2x. We are going to substitute what 2x into what the differential equation and find out whether the left hand side will be equal to the right hand side. When I do this, when I substitute this 2x into this differential equation, I have what 2x equals what 2x, and therefore I have what the left hand side to be equal to what you have the left hand side to be equal to the right hand side. So the function f of x is what is a solution to what to this differential equation that we have here. Okay, so what I have here, which is what the the f of x over the x equals what 2x. I can write this as what y prime, okay, equals what 2x. So from what we have here, we now know what y prime to what 2x. So we just substitute it. Then we have what the differential equation to what 2x equals what 2x. Okay. So you see that what after substituting this y value here into this differential equation here, we got what the left hand side to be equal to what the right hand side. So what you see that what the function here, okay, is a solution to what to the differential equation that was given. That's how to verify if a function is a solution to what a differential equation. Let's take another example. Okay, so let's look at this example also. So I'm going to verify whether what y equals e to the power minus 3x plus 2x plus 3 is a solution to what this differential equation that we have here. Okay, so you have the differential equation y prime plus 3y equals 6x plus 11. Then we have the solution to be e to the power minus 3x plus 2x plus 3. So we have to verify whether what this given function here, okay, is a solution to what the differential equation. So what that means here is that what for this differential equation here, okay, you see that what on the left hand side we have the function, that's the derivative of the function here. Okay, we have the first derivative of the function here, and then we have what 3 multiplying what the function also. What that means is that what when you substitute the first derivative of this function, okay, and then its derivative into this differential equation, the left hand side should be equal to the right hand side. That's what that means. Okay, so let's see if this will be true. Okay, so this is 6x plus 11. Okay, so I'm going to substitute the first derivative of this function here, and then the function itself into this differential equation, and see whether we get the left hand side to be equal to the right hand side. If the left hand side equals the right hand side, then what it is true, which means what this function is a solution to the differential equation. But if you don't get the left hand side and the right hand side to be identical, then it will not be a solution to the differential equation. Let's find out. So we need the first derivative of this function of what x here. So that be y prime will be equal to what we are going to apply our chain rule here. So we are going to find the derivative of what this whole thing, then multiply by the derivative of what you have on top here. So that what minus 3, okay, multiply what e to the power of minus 3x, okay, plus the derivative of what 2x, that what 2, then the derivative of 3, which is a constant, to what 0. So I'm going to substitute this first derivative and then this y here into this differential equation, and so that we get the left hand side to be equal to the right hand side. So let's look at that. Okay, so that will be minus 3 e to the power what? Minus 3x, okay, plus 2. Then plus 3 multiplying the function itself. So that was e to the power minus 3x plus 2x plus 3. Okay, so I'm going to verify if this expression that you have on the left hand side will equal to what you have on the right hand side, which is what 6x plus what 11. We're going to find out if what you have on the left hand side equals what you have on the right hand side. So let's see. So further simplifying this, how about minus 3 e to the power of minus 3x plus 2. Now I'm going to eliminate the bracket by what? Distributing this 3 to the values in the bracket. So that what 3 e to the power minus 3x plus 6x plus 9. And it should be equal to 6x plus 11. And I'm going to find out whether what it will be true. Okay, so when I do this when I do this minus 3, okay, explain to what minus 3x here, okay, will be added to what you have here, okay, and those values will cancel out because what you have negative here and then you have positive here, so that will give us what 0. But then you have what 2 plus 6x plus what 9 to be equal to what 6x what plus what 11. So in further simplifying this, we get what 6x plus what 11, and that is equal to what 6x plus what 11. So we have on the left hand side to be equal to the right hand side. So therefore, the function y equals e to the power minus 3x plus 2x plus 3 is a solution to the differential equation y prime plus 3y equals 6x plus what 11. Let's take another example. Okay, so with this example also, you have to verify whether what this solution here, okay, satisfies what this differential equation here. So you have to show that what y equals e to the power minus x plus sin x is a solution to this differential equation. So in this differential equation, so that we have the second derivative of what the function y, okay. So we have what the second derivative of what this function what y here plus what the actual function giving us what 2 multiply what exponent what minus x. So we are going to verify whether the left hand side will equal to the right hand side. So we are going to write down the solution, which is y equals e to the power of minus x, right? And we need what the second derivative of what this solution here, because what the differential equation contains what the second derivative of what of the function of y, okay, with respect to x. So we need what the second derivative of what this function here, and substitute it in place of what this value here, and then verify whether what you get the left hand side to be equal to the right hand side. And before you can get the second derivative, you have to what find the first derivative. So the first derivative, which is what dy over what x, will be equal to what minus e to the power what minus x, and the second derivative, which is what d squared y over the x squared, will be equal to what e to the power minus x. This is what we have. So I'm going to substitute what you have here, okay, and then the function itself into what the differential equation, and out whether the left hand side will be equal to the right hand side. So when I do this, I'll have what e to the power minus x, okay, plus y, okay, plus y, which is what e to the power minus x, and this will be equal to what 2 e to the power minus x. So we are going to further simplify this. This will give what 2 e to the power minus x equals 2 e to the power minus x. So we therefore have the left hand side to be equal to the right hand side. So therefore, this function here is a solution to this differential equation, because what when substituted the function and then its second derivative to the differential equation, we got what an identity, which means what it satisfied the equation. or it made what the statement true. So therefore the function is what a solution to the what differential equation. So I'll give you some example to try your hands on. Please make sure you subscribe and then turn on the notification bell so that you receive updates when I upload new videos on this tutorial. Thank you very much.